In this tutorial, we'll learn how to read data that's displayed on the screen. In the bottom right-hand corner is data concerning the stack number, the slice number, and the zoom factor. In the bottom left-hand corner is data concerning the XY coordinates of the cursor tip, the window center and width, and the absolute slice position and thickness. In the center of the left-hand part of the screen are numbers displaying the radiodensity found at the tip of the cursor. In the upper right-hand corner is data displaying the time and date when the CT study or MRI study was carried out. As a rule, anytime we begin a new radiographic case, it's usually best to set up our screen to display 3 different tiles. In this case, we have displayed our axial sections over in the left window tile, our coronal sections in the middle window tile, and sagittal sections in the right window tile. Now to start, we want to activate our axial screen. So I'll click on that once. And you notice that these axial sections are taken from our second stack of raw CT images. If we go up to the left-hand corner, we can see the possible image stacks that we could display, and the second image stack is located at the cursor, and there are a total of 272 images in the stack. If I want to display the next stack of raw CT images, I go over to the next block here, left click, keep the left click down and pull the image into the window. So this will be the third stack of raw images, and once again you see that the number has changed to 3. Let's look at our second image stack as we started off. So I'll left click, pull it down, and there you have it. Now, since we just moved in the axial sections, you notice that we're looking at the first image in that stack. If I use the wheel on my mouse, you notice that the images are changing, and now I'm displaying the 20th image in that stack. If I continue to move my wheel on my mouse, I can continue to scroll down, and I notice I can scroll down because the yellow lines in the coronal and sagittal sections are getting progressively lower in the body trunk. If I stop right here, let's go a little bit lower. If I stop right here, mid-thoracic region, I'm at the 88th image. You notice that in the lower right-hand corner, we have a zoom factor of 1.02. If I want to increase the magnification, I go down to my toolbar. I go to the binoculars, the move zoom tool, left click. Then I right click, and I can change the magnification from 1.02, let's say, to 1.5 or 2. Let's change it to 2.5. And you notice that the image is larger, and our zoom factor is now at 2.5. I'm going to return to our original value of our zoom factor of 1. Now let's look at the writing in the bottom left-hand corner. At the top line, we see something that says x/y 135 511. That gives you the XY coordinates of where my cursor is located. If I move my cursor to a different part of the screen, you notice that the XY coordinates of that cursor are different. Now, I'm just going to double click on the axial section so I can just display that one image. Now, if I go all the way up to the very top left-hand corner, it's hard to do, but approximately right here, my XY coordinates would be 0/0. If I go to the bottom right-hand corner, go in a diagonal line, you notice that the XY coordinates are getting larger and larger and larger, and eventually I can reach 512 by 512. These are the absolute XY coordinates of the pixels of this CT image. What happens if I change magnification? Put my cursor in the middle of the descending aorta, and you notice that the coordinates there are 269 by 291. Those are absolute coordinates of where the descending aorta is. Do those coordinates change when I change magnification? The answer is no. So I'll prove that by bringing my cursor to the bottom of the screen, go to magnification, right click, and let's go to a 3x image. Put my cursor in the middle of the descending aorta. Once again, it's 269. So it doesn't matter what the magnification of the image is. The XY coordinates of every pixel remains absolutely the same.
Our windowing right now is set at a width of 350.
XY coordinates are the values for my windowing. Which means that there are 250 different values for our gray colors, and the center of the scale is 40. Now, once again, let's go down to our toolbar and change our windowing values. I'll left click on windowing, I right click, and let's change the windowing to optimize the viewing of bones. So I'll click on bones. You notice that the image has changed. It looks very different than it did before. We see bones better, but the soft tissues are hard to see. And my windowing values now are width 1800, center 800. Now, if I want to change the windowing, let's say to look at lung. Bone is not seen so well, but the lungs are displayed more clearly. And once again, the width in this case is 1400, and my center is a negative 400. Let's return to bone because that's what we want to study initially. The last thing that we see in the bottom left-hand corner is slice position and slice thickness. Slice thickness is the thickness of every slice in this stack. So they're taken at 2.5 millimeter intervals. Slice position is the absolute position of this slice in this series of slices. We don't use slice position very often. The next number we want to look at is located in the middle of the left-hand part of the screen. Right now it displays a number of negative 45. What this number represents is the radiodensity found at the tip of the pointer. So if I go, for instance, to air, which is outside the body, you notice that the radiodensity is a negative 968.
Is the reference point from which all Hounsfield units are measured. This table shows the radiodensity typically found in most tissues. The values are in HU units, which stands for Hounsfield units, which is the standard by which the radiodensity is measured in CAT scans and MRIs. Note that 0 is water, and that's the
last thing that we want to look at on this screen is found up in the upper right-hand corner, and that will show us study time and study date. These values are very valuable, particularly when writing up your reports. It tells you when this CT study was done. Sometimes it's necessary to monitor the patient at different points of time during the day or over a period of a day, week, or months, and see if the anatomy, particularly the anatomy that looks abnormal, if it changes. If it's a hemorrhage, we can ask the question, is the hemorrhage getting bigger or smaller? If it's a tumor that we're interested in, is the tumor getting bigger and smaller? If it's an inflammatory response, is the inflammation getting bigger and smaller?